Okay, so if you are absent today, or you are quarantined, no big deal. We are doing a density graph today. So I'll post a key to the density graph or the density lab on Canvas later. But for now, we are going to do a graph lesson on how to graph density visually. So the first thing to do is you just set up a graph. So I'm going to just make my x and y axis just big enough so I got plenty of room. Looks like it was a little off on that, so I'm going to go ahead and just make sure it's more uniform. Okay. All right, so I got my graph, and the first thing that I'm going to do is title it. So my title will be Relative Density of Substances. And by density, I'm going to go ahead and hold it up. So relative density of substances, and what I'll do for density is go ahead and write the units next to it. So in parentheses, I'll write grams per milliliter. Now, I'm just going to write grams per milliliter because we do have some liquids on there. We also have some solids. So even though those would be grams per cubic centimeter, I'm just going to do grams per milliliter. And actually, I'll write or centimeter cubed. We'll just do that. So to divide it into liquid or solid, depending on what it is. So the next thing is I need to label my intervals. So and pick which axis. So remember, this is our y-axis, which is going to have our dependent variable. And our dependent variable is going to be the number of grams. Okay, so we're going to put gram here on this axis. And grams are units, which describes the mass, right? So we're going to put grams in parentheses. You could also just write a G for that. And then we're going to have mass in grams for our y-axis title. And for the intervals, I'm going to give myself, I'm going to go up by 2 lines for every 1 gram. So I'm going to start at 0, and then I'm going to go 1, 2, 3, 4, and so on. Now, your graph only needs to go up to about 14. We will have a substance that will exceed that, but I'm not going to worry about that on this graph. So the next thing that we do is we have our graph labeled, right? And so what we'll do next is we are going to put the x-axis title. So for the x-axis, we're going to have volume. And that will be in cubic centimeters or milliliter. So that's what our x-axis title is. And then our independent variable is volume. So the next thing that I'm going to do is start labeling my intervals for that. I'm going to go every 4 lines for 1. So I'm going to go up by a quarter of a milliliter or cubic centimeter every line. So to simplify that, I don't need to write a number on every line. So I'm going to work smarter, not harder, and just write the halves and the whole numbers. So we'll have 0.5 here and then 1. So that shows you that, let me bring this a little bit closer. That shows you that would be 0.25, 0.1, so that's a quarter, a half, 3/4, and 1. And I'm going to keep that scale and keep going. So this is going to be 1.5, 2, 2.5, and 3. Now, I'm only going to go over to about 3 because I really don't need to go any farther than that for this graph. So make sure that you have up to 14 on the y-axis and up to about 3 milliliters or cubic centimeters on the x-axis. So now what do? Where's our data? Now, for reference, you can access this on the Canvas page. To save time on the video, I'm not going to link into Notability and do this. I'm just going to show you where I'm getting this. So in yesterday's density lab, on the second page, you had a chart right here. And this chart has various substances. If you are absent, since I only went up to 14, we're going to do everything except gold, because gold is going to have a mass of its density is 19.3, and that's grams per centimeter cubed. So that's going to be a very high slope. So what I'm going to do is do everything except gold. Our lowest values, we have 3 beneath 1. We have wood, specifically oak, is 0.59 gram per centimeter. And then we have vegetable oil is 0.89, and then we have gasoline, which is 0.7. So we're going to do those three first. So all you have to do for this is you find 1 milliliter, okay? Because those values are all per 1 milliliter. Our lowest was oak, which was 0.59. 0.59 is going to be basically halfway between 0 and 1. So on this line, I'm going to find 1 milliliter and put a plot there. So 0.59 is just going to be just over that. And then my next value is going to be, let's see, that would be gasoline at 7.7. So that's going to be right above that. And then my next value is 0.89, and that's vegetable oil. So all three of those are beneath 1. So it's really important that you go up 2 lines for every 1, because you need space for examples like these. And I'm going to have pure water, which is exactly at 1. So I'm just going to do these first 4 lines, and you guys can do the rest. All you have to do is once you have those plots pointed on the 1 interval for volume, you're going to go ahead and just take the origin of the graph and intercept that point. So I'm going to go to 0, find my lowest point, and voila. That is how you do density. So a density curve is always going to increase, because the more volume you're going to have, the more mass you're going to have per volume, and it's a steady curve. Your density is not going to exponentially increase or curve as it goes farther to the right, because your substance identity, like oak wood, does not change to gasoline. It stays as oak wood. So that means that it's going to maintain the same steady slope for its density line. So we have these first 4 lines, and all I need you to do is for each line, preferably where you have more space, label these. So my lowest was wood. My next one was gas. My next one was vegetable oil. And the next one was water, pure water specifically. So that's the first 4 lines or substances on here, and what you're going to have to do is just, again, use this chart on page 2 of our density lab, which we did in class yesterday, and do every other substance beyond water, since we just did those 4 together, and keep going up to let's see, lead. Once you get to lead, stop. You don't need to do gold. And the other part of that is you'll notice the pattern that the less dense something is, the lower the slope is going to be on the graph. So this is a little confusing to people, because from yesterday's lab, we saw that in the test tube, which I'm just going to draw right here on the graph, we saw that in the test tube, if you were less dense, you were towards the top. Okay? If you were more dense, you were towards the bottom, because you were so dense that you had to be at the bottom and everything else floated on top of you. Whereas on a graph, if you're less dense, you're actually towards the bottom of the graph, because you have the least mass per unit volume. So that can be a little confusing when you compare floating substances and density to how they come up on a graph. They are kind of opposite that way. But if you just focus on the methods behind graphing, it really shouldn't be very difficult. Please email me if you have any questions. And if you don't have any graph paper, just go ahead and try to measure one with a meter stick, or email me if you need another alternative. You can also try graphing on Notability.